Hello everyone, welcome to Elevare. This is Fahim and today we'll be solving the paper from Edexcel IAL Chemistry Unit 1 and the year is gonna be 2026 of January. So without wasting any more time, let's just crack this paper down. So in the first question it says that which property determines the order of elements in the periodic table. Okay. Ionization energy, atomic mass, number of electrons, or the number of protons in the nucleus. Okay, so let's just take a look at the periodic table first of all. It's given the very bottom down. Okay, so what I could see from here is that elements are arranged from left to right. Now what can I see? What can I see? Like, what's the obvious pattern that I could see? The elements are arranged in terms of their atomic number, right? The elements are arranged in terms of increasing atomic number. See, from left to right, there is one thing that is being increased noticeably, right? That is the number of electrons, right? See, the number of electrons, or the number of protons, or you could say the atomic number, is increasing from left to right? So what you could say is that they are arranged in terms of their proton number in the nucleus, right? So if you were to say this, then the answer should be the number of protons in the nucleus, right? So yeah, moving on. Which atom has the most orbitals that contain a single electron, right? Which atom has the most orbital that contain a single electron? So first of all, what you have to do is you have to first of all write the SPD configuration and then draw a box plot and then see which of them has the least number of electrons in their orbital, in one of their orbital. Okay, so what you have to do is first of all you have to draw the SPD configuration of each of these, right? So this is the atomic number of carbon, this is the atomic number of chromium, this is the atomic number of manganese, this is the atomic number of nitrogen. And then what you have to do is you have to write down the SPD notation of this, right? Now if you write down the SPD notation of all of these and then draw the box notation for each of it, right? So let's just assume for nitrogen, in S1s there are 2 electron, in 2s there are 2 electron, and in 3p there are 3 electron, right? So if you were to draw the box plot notation and the SPD notation of all of this, what you could see from here would be that chromium would have 1 electron in S and 5 single electron in D, right? Since this is a D block element. Hence, the answer is gonna be B. Now, if you were to draw the box plot for all of them, you'd see that chromium have the largest number of orbitals, have the greatest number of orbitals that contains a single electron, right? So B should be the answer of it. Now, if you're still confused about this, let me just show you once more. Okay, for S there are going to be 2, for S there are going to be 2, for P there are going to be 2, right? So what you could see from here is that there are two single electrons over here in an orbital. From here what you could see that is there are gonna be 5 single electrons in this D orbital. How? So let's just draw this down. 1, 2, 3, 4 and 5, right? 5 single electrons, and over here you have 3 single electrons, but see over here you have 5 plus 1, 6 single electrons in an orbital. So the answer should be B. I hope you are clear with the working of this. The electronic configuration of element X is this. Okay, now what is the formula of the compound form when X reacts with potassium? Okay, so first of all what you have to know is that the charge of potassium ion is going to be K plus 1, right? Now let's just figure out what X is. Okay, now how many electrons are there in the outer shell of X? First of all, let's just figure this out. So let's just take a look at it, right? This is for the first shell, this is for the second shell, and this is for the third shell or the outer shell. And in the outer shell there are 2 electrons, in the outer shell there are 4 plus 2. in the outer shell there are a total of 6 electrons, right, which means that it can gain a total of 2 electrons surplus, right. Now if it can gain a total of 2 electrons, then it is going to have an overall charge of 2 minus. I hope you are clear with this. Take a look at it over here. So there are 4. This 2 belongs to the third shell, right. Now there are 2 electrons over here, there are 4 electrons over here, so that brings to a surplus of 6 electrons. Now it can gain an extra amount of 2 electrons to get an octet, right. Now if it gains an extra amount of 2 electrons, it is going to have a charge of 2 minus, right. So K plus 2 minus, cross the charge out. What you could find from here is that K2x is going to be the formula of the compound, K2x. So B is going to be the answer of it, right. Now the working of it looks something like this. And this. I hope you are clear with this. So the answer is going to be B, K2x. Moving on. Now in question 4, it says that which ion is not isoelectronic with other ions. Okay, so what does this mean? Isoelectronic means that they have the same number of electrons. If something is isoelectronic, then it is going to have the same number of electrons. So from here, which doesn't have the same number of electrons, just figure that out and you'll have your answer. Okay, now what you could see from here is that for titanium, the atomic number or the number of electron is going to be 22, since it has a charge of 3 plus, which means that there are going to be a shortage of 3 electron, right. So 22 minus 3, you would have a total of 19 electron. For calcium atom, this is going to be 20 electron, right, but when it forms an ion of charge plus 2, it is going to have how do I even say this, it is going to have a shortage of 2 electrons, you could say. When it forms an ion of plus 2, it is going to have a shortage of 2 electrons, right. So 20 minus 2 is going to be 18 electrons. Now we do the same for this 2 as well, and if you do it, let me just show you for negative 1, right. So for chlorine atom, it is going to have atomic number of 17 or electron number of 17, but when it forms an ion, it is going to gain 1 more electron, right. So the number of electron is going to increase from 17 to plus 1, which is of gaining an electron, to 18 electrons, right. So what you could see from here is that these 3 have the same number of electrons, since these are isoelectronic, whereas A has a different number of electrons when compared with the other 3. So A is going to be the answer of it. Okay, moving on. Now, which properties of a cation results in the greatest polarizing power? So to remember this, I basically tell my students to remember the Coulomb's law, which says that F is directly proportional to Q1 Q2 R square, right. Now what basically is this F? F is the electrostatic force of attraction. These are the charges and this is the radius. Now if the charge increases, then this force of attraction is going to increase as well, and the cation is going to pull the anion cloud more. And if the radius decreases, the force increases as well, because they are in an inversely proportional relationship. Hence the cation is basically going to pull the anion cloud more. It is going to distort the anion cloud more, right. So this is the cation and this is the anion cloud, right. Now if the polarizing power of this increases, what the cation is going to do is that it is going to distort the electron cloud of the anion, right. Now these are the two possible combination that is going to increase the polarizing power of a cation. Now radius is obviously going to be small and charge is going to be large, right. So C should be the answer of this. Moving on. Question 6. The first 5 ionization energies of element Z are shown. Okay, so 1 2 3 4 5 6. What is the formula of the most stable chloride of Zl? Okay, chloride. Okay, so Cl minus. Now what you have to figure out is that what is going to be the charge of Z. Now to figure out the charge of to figure out the charge of this Z or Z, what you have to do is you have to figure out what group does it belong to. Now, first of all, in the ionization energy, why is there are where is where can you find a large jump between the second and third ionization energy? There is a large jump. It means that it is a group 2 element. Since there is a large increase in ionization energy between the second and the third one, it means that this thing belongs to group 2 of the periodic table. So the charge of Z is gonna be 2 plus, and chloride is gonna be obviously minus 1. So Z 2 plus Cl minus, you cross it out, right? So Z Cl2 is gonna be the answer of it. So C should be the answer of it. I hope you're clear with this. Okay, this is the working of the question, and yeah, C should be the answer of it. Moving on. Which is not a neutralization reaction, an acid base reaction, right? Now, acid plus metal, salt plus hydrogen, acid base. Acid plus base, salt plus hydrogen, acid base. This is a base, this is acid, acid base. Oh, wait. Just a moment. No. I made a mistake. Sorry for that. This is an acid plus base reaction. Base, acid. This is carbonate, acid, acid base reaction. But wait a moment. This isn't an acid base reaction. How? So the oxidation state of zinc is going to be 0, but over here it is plus 2, right? Now for hydrogen, this is going to be an oxidation state of something over here, but now see, it is 0 because that is neutral, right? So there is a change in oxidation state, which means that something is gaining electron and something is losing electron, right? And that basically means that this is not a neutralization reaction. This is basically a redox reaction, since there is going to be a change in the oxidation state of the elements that are being involved. Okay, so yeah, this is gonna be the answer of it. So you could easily figure out the oxidation state of hydrogen, but I'm not showing that in here. Let's just say X, and over here it is going to be 0, and zinc is going to be plus 2, and zinc is going to be over here. So since there is a change in oxidation state, so there is going to be a loss and gain of electron, and hence this is a redox reaction. So our answer should be A for this question. Moving on. A hydrocarbon contains 82.8% carbon by mass. What is the molecular formula of the hydrocarbon? Okay, now in hydrocarbon there is only gonna be carbon and hydrogen, nothing else than that, right? It comprises of carbon and hydrogen. Now take 100 to be the total percent. If 82.8 is the percent of carbon, then subtract 82.8 from 100 to figure out the percentage of hydrogen, right? Once you have the percentage of hydrogen, you figure out, you divide by the MR of each of the compounds. Okay, you find the smallest mole and then you divide with the smallest mole and so on, right? The basic one that we have been doing since grade 9, you could say. Okay, this simple thing that we have been doing since grade 9. Okay, so you figure out the percent of hydrogen, you then divide this with the MR of them. Which one has the smallest MR? 6.9. For carbon, you divide both of them by 6.9. Then what you do is, basically, since this is a decimal, what you have to do is you have to make it a whole number. So what I did was multiplied it by 2, and it came around 4.9, which is equivalent to 5, right? So the answer is gonna be C2H5, right? Now this is basically the empirical formula of the compound, and they have asked for the molecular formula. So what you have to do is you have to take the multiples of it, right? So 2, 5, right? So what could be the possible multiple of it? Times 2, C4H10, because if you divide this by 2, you're gonna get this, right? C2H5. So the answer for this is gonna be this one, C4H10. Just give me a moment, guys. Give me a moment. Moving on. what is the percentage composition by mass of nitrogen in this. Okay, so nothing, mR of nitrogen divided by total mR times 100. If you do this, you'd get the answer to of this question, right? So yeah, AR of nitrogen total mR times 100. How many nitrogen are here? There are gonna be 2 nitrogen, 8 hydrogen, 4 2s are 8, right? 4 2s are 8 hydrogen, sulfur, and 16 oxygen. And times 100, you'd get the answer of it. And if the answer of it is gonna be 21.2, so the answer is gonna be B. Easy stuff, right? Moving on. Now, what is the total number of ions in 10 gram of this iron 3 sulfate? The molar mass of iron 3 sulfate is this, and Avogadro's constant. Okay, so total number of ions is going to be what? Total number of atoms, total number of ions, total number of molecules. All of them are going to have the same formula. So N times L times N times L times number of ions. Number of ions, let's just say X, right? So N is what? N is the mole of it. So mole. How could you figure out the mole? Mass, mR. L is Avogadro's constant, 6.02. And what is X? X is going to be the number of ions that you could see over here. So in here, you have Fe2 plus and SO4 2 minus, right? Now, how many Fe2 plus do you have? You have 2 of it. And how many SO4 3 minus do you have? You have 3 of it. So what is the total number of ions? You have a total number of 5 ions over here, right? Now you plug it into the equation and you get an answer of this, right? So the answer should be 7.5 into 10 to the power 20 to 10. Moving on. What mass of barium chloride is needed to make 500 centimeter cube of 0.100 mole per dm cube of solution? Okay, so what mass of barium chloride is needed to make this centimeter cube of 0.100 mole dm cube of a solution, right? So how you're basically gonna solve this question down. Okay, now first of all, easy stuff. You could easily figure out the moles of barium chloride solution. How? Number of moles, volume times concentration. If you have the number of moles, what you could do is number of moles is going to be equals to mass by mR. So for barium, the molar mass is given. For chlorine, the molar mass is given. You have N, you have mR. Then what you're going to do is you're going to make the mass the subject and figure out the mass easily, right? Easy question. So number of moles is this. You have the number of moles, right? Plug it into the equation, and this is the mR. You make mass the subject by multiplying this 2. You're going to get a value of 10.42 gram, right? So the answer is going to be C. Moving on. Methane burns completely in oxygen as shown. Okay, methane plus oxygen leads to the formation of carbon dioxide and water. 50 centimeter cube of methane was mixed with 200 centimeter cube of oxygen, okay, and the mixture was ignited. What is the total volume in centimeter cube of the gas mixture at the end of the reaction? All the volumes were measured at the same temperature and pressure. I mean, what is the remaining volume of gas at the end of the reaction is basically what they're trying to say in short. Okay, so let me just teach you a shortcut method of doing this. When you have gaseous reactants, the volume of the gas is directly proportional to the number of moles. Volume is directly proportional to number of moles if you have gaseous reactants. Now, completely burns in oxygen, right? Which means that there is going to be an excess amount of oxygen. Completely burns, right? Which means that the amount of oxygen is in excess. So, if the volume of methane is 50, as I said, oxygen is in excess, right? We have to figure out the volumes of this. Now, if the volume of methane is 50, the volume of carbon dioxide is going to be 50 as well, and the volume of hydrogen, water, steam is going to be, water vapor is going to be 100. 50 times 2. We are comparing the molar ratio 1 to 2, right? Now, if this is 50, the volume of oxygen is going to be 100. Now there's a catch. This is the volume of oxygen that is needed to react with 50 centimeter cube of methane. This is the volume of oxygen that is needed to react with 50 centimeter cube of oxygen. Now how much was the volume of oxygen that was provided to you? It was 200, right? So what is the volume of unreacted oxygen? So the volume of unreacted oxygen is going to be 200 minus 100. This is going to be 100 centimeter cube. And what is the volume of product that is being formed? 50 and 100, right? So 100 plus 100 plus 50. So you would have a volume of 250 centimeter cube of gas that remains at the end, right? So the answer for this question is going to be C. Now this is a extremely common question that you are going to encounter in your exam. Make sure that you're clear with the concept. Either you do this, or either you take the longer route, figure out the moles and do everything. I mean, you take this route, okay? You take the longer route, figure the moles of it, then you figure the moles of it, then you figure the moles of it, then you figure the volume of this, you figure the volume of this, you do the same with this and so on, right? Either you do this or you basically use the thing that I said. Number of mole is directly proportional to what? The volume. When all of the reactants are in gas, all reactants are in gas. You either use the trick or you basically stick with the normal route of it, okay? So yeah, moving on. What is the volume of this moles of oxygen at 250 degree and at pressure of this, okay? So PV equals to nRT. PV equals to nRT. You make V the subject, nRT divided by P, right? Now what you have to do is, the temperature is in degrees Celsius, you have to convert this into Kelvin, right? So temperature in Kelvin equals to temperature in degrees Celsius plus 273, right? You do this to figure out the temperature in Kelvin, okay? And all of the values are given, you plug it into the equation and figure out the value of it, right? So yeah, if you make volume the subject, you're gonna have an answer of this, right? Now the thing is that the volume from this equation comes in meter cube, but your answers are in centimeter cube and dm cube. So what you're going to do, so first of all, let's just convert this meter cube to centimeter cube. How you're going to convert meter cube to centimeter cube? You're going to multiply with 10 to the power 6 or 300, right? If you do this, you're going to get a value of 217 centimeter cube, and that basically fulfills the criteria, right? That basically fulfills the criteria. So the answer is going to be B, 217 centimeter cube. Moving on. I hope you're basically clear with these decent mathematical conversions. Okay, moving on. Now, which reaction has the lowest atom economy by mass for the formation of calcium chloride? Okay, so atom economy, the formula of it is MR of desired products by total MR times 100. Total MR of all product times 100, right? Now you're going to do this for each of them and figure out the value of it. So atom economy, the formula is MR of desired product divided by total MR times 100. So let's just say for this one, right? Figure out the MR of calcium chloride divided by the total MR of each of it and multiply it with 100. And if you do this, you're going to get an answer of what? A should be the answer of this question. Okay, you do for each of them individually, you'd figure out that A has the highest atom economy, so A should be the answer of it. 15. When one molecule of C10H22 is cracked and reformed, which of these mixtures could not be formed? Okay, this is a pretty simple question. So what you're gonna do is write down the formula for each of them and then add this together to see the total number of carbon and hydrogen that is being formed, that both of the compounds has, right? So you first of all write the formula for each of them, and then you figure out the total number of carbon and hydrogen that are present, right? And you then match this total number of carbon and hydrogen with the initial carbon and hydrogen number. Now the one where the number of carbon and hydrogen at the end does not match with this should be our answer. So the one that at the end where our answer doesn't match is going to be this, right? So C10H20. So this cannot be formed. So our answer should be D for this question. And about this formulae, I hope you know how to do it, okay? So let's just say, how do you write this one? So let's just say cyclobutane, right? So for cyclical compound, the general formula is CnH2n. So cyclobutane is going to have a formula of C4H8 and so on, okay? So if you are unsure about writing this directly, what you could do is you could basically even draw the displayed formula and then figure it out, okay? So these are some of the maths that you should be clear with. These are some of the stuff that you have to be clear with at this point, okay? So moving on. How many sigma bonds and pi bonds are in the molecule? Okay, so whenever there is a single bond, these are all sigma bonds, and whenever there is a double bond, the first one is going to be sigma and the second one is going to be pi. Single bond sigma, when there is a double bond, first one is sigma, second one is pi. If you do this, you would figure out that there are 10 sigma and 2 pi bonds, right? So if you do it, then the answer is going to be sorry, just a moment, I feel like I made a mistake. Okay, I made a mistake. There are gonna be a total of 12 sigma bonds. Count this down, you'll figure out 1 2 3 4 5 6 7 8 9 10 11 12. There are a total of 12 sigma bonds and 2 pi bonds, right? So the answer is gonna be C. Just a moment, guys. Moving on to question number 17. Which two organic compounds are isomer? Okay, so for something to be isomer, they are going to have the same molecular formula, and the structural formula, displayed formula could be different as well, right? So figure out the molecular formula for each of them. Now the one that have the same molecular formula are gonna be what? Are gonna be isomer, right? So for this, how many carbons are there? 1 2 3 4 5 6. And how many hydrogens are gonna be there? 1 2 3 1 2 1 1 1 2 1 2 3, right? So 1 2 3 4 5 6 7 8 9 10 11 12 12 hydrogen, 6 carbon, right? This is a cyclical compound. So 1 2 3 4 5 6 7 8 9 10 hydrogen and 1 2 3 4 5 carbon, right? You do the same for these and this. Now if you were to see, these and these have the same molecular formula, but see, the structure is going to be different. So 1 and 4 are going to be isomers of each other, right? So B is the answer of it. Moving on. Now, how many structural isomers have the formula of this, right? So first of all, try with the positional ones. 1 2 3 4. Br is positioned over here, Br is then positioned over here, right? Then what you could do is you could basically make chains of the compound, right? You make branch of the compound, you make branching. Right? Br is attached over here first, then Br could be attached over here, right? So there are 2 with the positional isomer, and there are 2 possibility with the branching one, right? So there is basically gonna be a total of 4 isomers. So answer is gonna be B, 4. Moving on. Which alkene exists as easy isomerism? Okay, so first of all, there needs to be carbon-carbon double bond, and there needs to be different group attached around the carbon that has this carbon-carbon double bond. All of the groups over here are going to be different, right? Now, if you were to draw this 2-methyl but 1-ene, okay, so 1 2 3 4 but 1-ene, and on the second carbon there is going to be a methyl group. So over here there is going to be hydrogen, there is going to be hydrogen. Since they have the same group around the carbon double bond, this is not a geometric isomer or easy isomerism, right? Now if we were to see this butene, you could see that there are different groups attached around the carbon that has this carbon double bond, right? So D is going to be the answer of it. 19, D is going to be the answer. Moving on, what is the IUPAC name of this compound? So first of all, figure out the largest chain or the longest chain. So what I could see is that 1 2 3 4. Let's just see 1 2 3 4. Okay, 1 2 3 4. Okay, so the longest chain, let's just take a look at it. Wait just a moment. 1 2 3 4 5, right? 1 2 3 4 1 2 1 2 3 4 5. Okay, so the longest chain has 5 carbon, right? So 1 2 3 4 5. So the parent chain is going to be pentane. So where is this going to be pentane? These and these. Eliminate these two. Okay, now there are some branching, right? You have to take into consideration the branchings as well. Okay, so this is a CH2 CH3, this is a ethyl group, this is a methyl group, this is another methyl group, right? So 1 2 3, right? So this is gonna be 2 3 dimethyl 2 3 wait just a moment. So this is gonna be 1 2 3 4 5, right? So this is gonna be, and this is a ethyl chains, right? So they are arranged in terms of their alphabetical order. So this is gonna be first, second, third, right? 3 ethyl 2 3 dimethyl pentane. So answer is gonna be D. 3 ethyl 2 3 dimethyl, there's going to be a methyl group on second carbon, third carbon, 2 3 dimethyl pentane. So the answer should be D. I hope you are clear with this, everyone. Okay, so now moving on to section B. Okay, the first question says that the question is about sodium and sodium fluoride. Okay, sodium and sodium fluoride. Describe the metallic bonding in sodium. Okay, so it is the electrostatic force of attraction between the cations, between the sodium cations and the delocalized electrons, right? This is basically the definition of metallic bonding. It is the force of attraction, it is the electrostatic force of attraction between the cations and the delocalized electrons. Okay, so yeah, this should be the description of it. Sodium ions and the delocalized electron. Moving on. Explain how melting temperature of magnesium compares with sodium. Okay, so first of all, the melting temperature for magnesium is going to be higher than when compared with sodium. Now why is it? Okay, so magnesium ions has a charge of +2, whereas sodium ions has a charge of +1, right? So first of all, the charge of magnesium ion is greater than that of sodium, and also there are going to be more delocalized electrons. There are going to be more delocalized electron for magnesium, so there is going to be greater attraction. So the attraction between the delocalized electron and the cation for magnesium is going to be stronger, and it would require more energy to overcome the attraction between the cations and the delocalized electrons in magnesium, right? Hence the melting temperature of magnesium is going to be higher when compared with sodium. So first thing is that greater charge, second thing is that more number of electron, hence greater attraction between the cations and the delocalized electrons in magnesium when compared with sodium. This is the answer, everyone. Just take a reading at it. Okay, moving on. Draw a dot and cross diagram showing ionic bonding in sodium fluoride. Use dots for fluorine and cross for sodium electrons. Okay, include all electron shells in your diagram. Okay, so it should look something like this: dot for fluorine, cross for sodium. One of the outer shell electron from sodium went to the outer shell for fluorine, hence it get an overall of minus and it gained an overall charge of plus. Moving on. Explain how sodium ions and fluoride ions explain how the sodium ion and the fluoride ion compare in size. Okay, so the thing is that Na plus ions are gonna be smaller, right? Na plus ions are gonna be smaller. Why? Because sodium Na plus has more protons. Fluorine has 9, but for sodium it is gonna be 11, right? Atomic number. Sodium has more protons, hence the electron shells in sodium, the electrons are gonna be attracted more strongly to the nucleus in sodium. As a result, the radius decreases. Since due to this attraction between the nucleus and the electron, the shells are pulled bit closer to the nucleus. Hence, the size of sodium ion is going to be smaller. This is the answer, everyone. Take a reading at it. This is what I have said so far. Moving on. Explain the electrical conductivities of sodium and sodium fluoride in solid and liquid states. As this sodium has metallic bonding, it can conduct electricity in both solid and liquid state. But for sodium fluoride, it needs to be in liquid state to conduct electricity. This is because this is an ionic compound, and ionic compounds, when they are in solid state, cannot conduct electricity. Why? This is because when the ionic compounds are in solid states, the ions are not free to move. The ions cannot move, and hence they cannot conduct electricity. So this is what I have written over here, everyone. Just take a reading at. This is basically something from your IGCSE chemistry. Take a reading at it. Once you're done, we'll just move on. Okay, moving on. Many toothpaste contains sodium fluoride because the fluoride ion has been shown to reduce tooth decay. Okay, a 1.0 gram of toothpaste contains these moles of sodium fluoride. Okay, calculate the concentration in parts per million ppm of the fluoride ions in this sample of toothpaste. Okay, parts per million. Okay, so mass of solute by mass of solvent, mass of solute, mass of solvent times 10 to the power 6. So for the mass of solute, how you are going to figure this out? So the number of moles of sodium fluoride is given, right? So you are going to multiply the number of moles with MR to figure out the mass of the solute. And the mass of the solvent over here is going to be 1, right? And you multiply it with 10 to the power 6. And it basically have your answer to this question. Okay? So it basically said for fluoride ions, right? So you have to multiply this with the MR of just 19 only. Okay? So yeah, mass of solute, mass of solution 10 to the power 6, right? So mole times MR. The question restricted you to only fluoride ions, right? So you're just going to multiply with the MR of fluoride ion only, not with sodium ones as well, 23.1, right? Just with the fluoride ions. Okay, so it should give you a ppm of this. Now it's said to approximate appropriate number of significant figure. Okay, so figure out the lowest number of significant figure in the question. I could see that 2 significant figure. Okay, so yeah, answer should be given to 2 significant figure. So for 2 significant figure, this is going to be 1100 ppm. 1100 ppm, right? So yeah, this is the answer to this question. I hope you're clear about this, everyone. Moving on. in question 22 it says that this question is about some compounds that contains halogen. Okay, draw a dot and cross diagram of a molecule for tetrachloromethane. Show the outer shell electrons only. Use dot for chlorine and cross for carbon atoms. Okay, easy stuff. Dot and cross diagram. Dot for chlorine. Okay, since I have taken this image from a Google source, now if you were to draw this you will get 0 mark, right? Because they have clearly said that you have to use dot for chlorine and cross for carbon, right? So there is gonna be a simple change to this. Okay, let me just draw this down. Okay, so dot and cross diagram. So let me just draw this down for you, just a moment. This is going to be your carbon and these are going to be your chlorines, tetrachloro. So 4 chlorines altogether. 1, 2, 3. These are easy questions, everyone. Please do not lose your marks in this type of questions. That's going to be my humble request to everyone. This is going to be chlorine, 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 dot for chlorine, right? So 1, 2, 3, 4, 5, 6, 7, dot for chlorine. Okay, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? And for carbon you have to use a cross, right? So for carbon you use a cross, right? So this should be the answer of this question. I hope you are clear with this. Predict the Cl bond angle in Cl4. Okay, so this bond angle, right? So first of all, see how many bond pairs are there and how many lone pairs are there around the central carbon atom, right? Around the central atom, what I could see is that there are 1, 2, 3, 4 bond pairs of electron and there are no lone pairs of electron, right? So this is going to be a tetrahedral arrangement, tetrahedral structure, and the bond angle is going to be 109.5, right? So yeah, there is going to be repulsion, and this angle basically minimizes the repulsion between the bonding pair of electrons. Okay, so yeah, this is the bond angle of it. Okay, and this is the answer of it. Moving on, everyone, just take a reading it. Okay, explain why CCl bond in CCl4 is polar but the molecule is non-polar. Okay, so there is going to be an electronegativity difference between these two, right? And whenever there is going to be an electronegativity difference between anything, that is going to be polar. The bond is going to be polar, but why the molecule is not polar? So to do this, draw the molecule Cl, 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 right? Now draw the dipole moment. See, the dipole moments are cancelling one another out, hence this is not a polar molecule. Clear? If the dipole moment adds up, that is a polar molecule. If the dipole moments do not adds up, that is going to be a non-polar molecule. That is not going to be a polar molecule if the dipoles are going to cancel one another out. Okay, so if you are not sure about how I did this, okay, do let me know in the comment section. If you do not know anything about dipole moments, I have a supporting video to this. I will basically attach the link of the video. Okay, moving on. This is the answer of the question. Okay, now what basically is the dipole moment, right? So let me just give you a brief recap of it, right? So from the electronegativity table, what you know is that chlorine has a greater electronegativity, right? So it would basically pull this bonding pair of electrons towards itself, right? Now this dipole moment shows what these electrons are being pulled to, in short. Okay, if the moments cancel one another out, then the molecule is polar. If the moment cancel one another out, the molecule is going to be non-polar. If the moment adds up or reinforces, then the molecule is going to be polar. Okay, and if it doesn't, it is going to be non-polar. I hope you are clear about this. Moving on, let me just restate this. Okay, So if the moments, dipole moments reinforces, it is going to be a polar. If it cancels out, this is going to be a non-polar molecule. Moving on. The oxygen atom in chloric 1 acid has two lone pairs of electron. Explain the effect that this lone pair have on HOCl1. Okay, this is basically like water. Okay, so there are going to be two lone pairs and two bond pairs, right? So the bond angle is going to be 1 of 4.5 degree, because there is going to be repulsion between the lone pairs, and the lone pair repulsion is greater than the repulsion of lone pair bond pair. As a result, it would basically cause this thing, it would basically cause the bond angle to decrease, right? It would basically push it inwards, so the bond angle decreases as per the VSEPR theory. Okay, valential electron pair repulsion theory. I hope you are clear with this, everyone. So this is what I have written over here. Just take a reading at it. Okay, so there is going to be repulsion between the lone pairs as well, and so there is going to be repulsion between the lone pairs and bond pair. Okay, moving on. This question says that a metal M reacts with hydrochloric acid to produce a metal chloride, okay, and a hydrogen gas. In an experiment, at the this moles 0. This moles of M reacts with this volume of this concentration of HCl, hydrochloric acid. The hydrogen gas collected has a volume of this at room temperature. And calculate the moles of hydrochloric acid. Number of moles, volume times concentration. You have the volume, you have the concentration. You have to make sure that this volume is taken to dm cube, obviously, in your answers. Okay, so to do this, you multiply with 10 to the power minus 3 or divide this thing with 10 to the power 3. Moving on. Calculate the number of moles of hydrogen gas that has been produced, right? So if you have the number of moles of this, right, you could easily figure out the number of moles of the hydrogen gas collected has a volume. Okay, so number of volume for gases is going to be volume by molar volume. You have the molar volume of this, you have the volume of this, you divide this and this, and you basically get the moles of your hydrogen gas. Okay, write an equation for the reaction between M and hydrochloric acid. Use your answer to C1 and C2 to figure out this question. Okay, so first of all, you have to write a balanced equation, right? Now what you have to do over here is that you have to divide with the smallest mole and figure out the simplest ratio first of all. Okay, so if you were to take a reading at it, you know the moles of this, you know the moles of this, and you know the moles of this, right? Now what you have to do is you have to basically divide with the one that has the lowest number of moles. So you divide with 0.0036. Okay, so you'd get a value of 0.5 to 1 to 0.5, right? Now you have to convert these numbers into a whole number, and hence I multiplied this with 2, so I get a value of 1 to 1, right? Now the thing is that you balance the overall equation. So there are two chlorines. Okay, so how can there be two chlorines, but there has to be one M, right? There has to be one M but two chlorines. So how can that be, right? If you were to add 2 MCl, now this wouldn't match because there are 2 M, right? But you have 1 M over here. So what would the logical approach be? It would look something like MCl2, right? And hence this is the overall equation of the reaction. I hope you are clear with this, everyone. Okay, so yeah, moving on. First of all, divide with the smallest number of moles, figure out the ratio, and then as per the ratio, solve it logically. Okay, moving on. Seawater contains bromide ions. Okay, an experiment was carried out to determine the concentration of bromide ions in seawater. Okay, 400 centimeter cube sample of seawater was added to excess silver nitrate solution and nitric acid. Okay, the precipitate of silver bromide was filtered, washed, and then dried. Mass of silver bromide is this. Calculate the concentration in mole per dm cube of bromide ion in this sample of seawater. Okay, so first of all, what you have to do is you have to figure out the MR of this AgBr. If you have the MR of AgBr, you could find the moles of AgBr. mass by molar mass, right? Mass is given, you could easily figure out the MR of it. Now what you have to do is you have to figure out the concentration in mole per dm cube of the sample, okay? So AgBr breaks down to form Ag plus Br minus. Now you have the moles of it, right? Now you could easily figure out the moles of it, right? Because they are reacting in a 1-to-1 ratio. If you have the moles of Br, then N of Br is going to be equals to volume times concentration. You have the volume of Br that is given 400 centimeter cube. You make concentration the subject and you easily figure out the concentration of bromide ions, okay? So yeah, Ag plus and Br minus this to the formation of this. You could easily figure out the number of moles of AgBr. Mass is given in the question, right? And this is the MR. Now Br is going to be the same because they are reacting in a 1-to-1 ratio. Hence number of moles of Br is going to be equals to volume times concentration. You make concentration the subject, you convert the volume into dm cube, and you get the answer of this 1.73 into 10 to the power minus 3 mole per dm cube. So yeah, moving on. Question 23. This question is about alkenes. Two reactions of propene are shown, okay? Reaction 1, reaction 2. Now over here alkene is being converted into an alcohol, and over here it is converted into a haloalkane, okay? Halogen plus alkane. Give the reagent and conditions for reaction 1, okay? So this is a really common reaction that you have to remember: steam, hydration reaction, okay, and phosphoric acid catalyst or sulfuric acid catalyst, okay? Steam, sulfuric acid catalyst. Moving on. Name the reaction mechanism and the product in reaction 2, okay? So the reaction mechanism is going to be electrophilic addition. Why? AgBr, it is electronegative, so it is going to pull the electron towards itself. It would obtain a charge of delta plus, and this delta plus would be trying to neutralize this charge by gaining electrons from these pi bonds, right? So this thing is what we refer to as an electrophile. Why? Because it is basically looking for electrons. It can accept a pair of electrons, and the name of the product is what? 1, 2, 3, right? So 2-bromopropane. Electrophilic addition and 2-bromopropane. Propene forms an addition polymer. Propene forms an addition polymer. Draw the displayed formula for the repeat unit of the polymer. Okay, so why is this propene, right? Repeat unit of this polymer is going to be what? Remove this. You do not need to write this, just remove this. This should be the answer, okay? So yeah, moving on. Just a moment. Okay, the number of double bonds in molecules can be determined using iodine number, okay? The mass in grams of iodine that reacts with 100 gram of the compound, is what we refer. The mass of iodine that reacts with 100 gram of the compound is called the iodine number, okay? The iodine number, the addition of iodine to a double bond is shown, okay? So when there is one double bond, there is going to be 2 iodine that are going to be attached. Compound X has a molar mass of this and 3 double bonds. Calculate the iodine number, okay? So what you have to do first of all is that you have to figure out the grams of iodine that should be added to 1 mole of X, okay? So what is the mass, or what is the mass of iodine that should be added to 1 mole of X, right? So for 1 double bond it needs 1 iodine, right? But whenever there are going to be 3 double bonds, so it needs a total of 1, 2, 3, 4, 5, 6. It needs a total of 3 iodine. It needs a total of 6 iodine when there are going to be 3 double bonds. First thing is that. So for 1 iodine is this, right? So for 6 iodine is what? 126.9 times 6. You would have the mass of iodine. Then what you know is that you have the mass of this compound and you have the molar mass of it as well. So just a moment. You have the molar mass of these, okay? and what you know is that it reacts with 100 gram of the compound, right? So this divided by molar mass times the mass of iodine should give you the iodine number of X. So let me just repeat. You first of all figure out the mass of iodine that compound, that 1 mole of compound X needs, right? So 1 mole of X needs 6 iodine, right? So 6 times this, okay? Because whenever there is 1 double bond, there needs to be 2 iodine, right? So whenever there is going to be 3 double bonds, so there needs to be 6 iodine, okay? You figure out the mass of it. Then what you know is that the MR of compound X is going to be this, but for that mass of iodine that reacts with 100 gram of the compound, right? So this is the mass of the compound. You have what? You have the molar mass of the compound as well, right? So this divided by 100 divided by this molar mass times the mass of iodine should give you the iodine number of it. I hope you're clear with it, okay? So let's just take a look at the working. Mass of iodine is this MR times AR times 6, and the iodine number is going to be what? That reacts with 100 gram of the compound. They have given you the mass. This is the molar mass of the compound, and this is the mass of iodine. So this should be the iodine number of it, okay? So 273.9. I hope you are clear with this, everyone. Okay, so question 24. It says that this question is about the mechanism for the reaction between alkenes and halogens, okay? So halogen and alkene reacts together in the presence of ultraviolet radiation to form haloalkenes, halogenoalkenes. Chloroethane can be made by reacting ethane and chlorine, okay? The equation for the reaction is that, okay? Ethane, chlorine reacting together to form a haloalkane, HCl. Initiation is the first step in this reaction mechanism and is shown, okay? So chlorine, each of the electron goes to one chlorine and it leads to the formation of free radicals. State the condition required for initiation step: ultraviolet radiation or UV light. State what this represents in the first step, right? Unpaired electron, a single electron, okay? A free radical electron, unpaired electron, let's just say it. Complete the mechanism by giving 2 propagation step and 2 termination step, okay? So 2 propagation step and 2 termination step, okay? So it should look something like this, right? This is a free radical and this is going to be unstable by itself. So what it is going to do is that, let's just say one hydrogen is over here, right? And this is the electron of hydrogen and this is the electron of carbon. So this free radical will tell the hydrogen to bring its electron and join with itself and lead to the formation of HCl, right? This compound is way more stable than this, and this is going to happen. Now since the hydrogen over here took the electron that it had, only the electron of carbon remains, right? And a subtraction of an hydrogen. So it basically leads to the formation of this compound. Now this compound would react with chlorine to take a revenge on chlorine itself, and you tell the chlorine, okay, so bring your electron with me and then let's just bind together and be stable. So this happens and this chlorine becomes single again, okay? Now the thing is that for termination step, 2 free radicals are going to react together. So for termination step, there are going to be 2 chlorine radical reacting together to form a molecule of chlorine, and 2 radical of this reacting together to form a molecule of this, C4H10. Okay, so when 2 free radical reacts together and ends the reaction, that is what we refer to as the termination step of the reaction. State why this reaction is not suitable for the manufacture of chloroethane. Okay, so you want to produce chloroethane, right? This is the product, but see what is being formed over here, C4H10 as well, right? So there could be further substitution for this reaction. You want this, but in the reaction this is being produced in the termination step of the reaction, so there is going to be impurities as well, right? So this is the answer of it. Moving on, everyone. Question 25. This question is about isotopes. Magnesium exists as mixture of 3 isotopes, this. Complete the table to show the number of subatomic particles for magnesium 25. Okay, so magnesium has an atomic number of what? Let's just take a look at it. Atomic number of 12, right? So subatomic particles, just a moment. So number of proton is going to be 12, electron is going to be 12, and number of neutron is going to be 25 minus 12, 13. Okay, so yeah. This is going to be 12 as well, just a moment. Moving on. State one similarity and difference between the isotope. What you could see is that all of the isotope would have the same number of protons, but if you were to figure out the neutron number, 25 minus 12, 24 minus 12, 26 minus 12, all of them would have different number of neutrons. This is what I have written over here. Just take a reading at it. Okay. The relative atomic mass of magnesium can be determined using a mass spectrometer. State what is meant by the term relative atomic mass. It is the average mass of an atom when compared to 1/12 of the mass of a carbon-12 atom. Okay, so you have to keep this memorized. This is a really common definition that they are going to ask in your exams. Okay, this is it. Okay, moving on. A simplified diagram of mass spectrometry is shown. Okay, so name the process that occurs in region A and B. So okay, in region A, ionization occurs. High energy electrons are shot towards the atom. Okay, and that leads to the formation of ions. And over B, magnetic field, so deflection occurs. Okay, so yeah, explain why a vacuum pump has to be used. Okay, so why a vacuum pump needs to be used in a mass spectrometer. Okay, so first thing is that, just a moment, let's just check. Relative atomic mass of magnesium. Okay, so why a vacuum pump has to be used. Okay, so if there wasn't a vacuum pump, water vapor would be present, and the ions and the water molecules would collide. Okay, so if there wasn't any vacuum pump over here, then water vapor would be present, or air particles would be present, or even air would be present. In air there is going to be water vapor, right? In air is going to be present, and over the ions over here would collide with these air particles, right? That would interfere with the ions, right? That would basically interfere with the results. So yeah, this is what I have written over here. It would basically interfere with the measurements or the results. It would deflect. It would basically interfere with the deflection of the ions. Okay, the simplified diagram shows the path for Mg2 plus, right? Draw the diagram for the path of Mg24 plus. Okay, okay, this thing has a high charge to mass ratio. It would be deflected less, but for this one, this has a lower charge to mass ratio, and since it has a lower charge to mass ratio, it is going to be lighter, so it is going to be deflected more when compared to this, right? So if this is the path of the normal one, Mg25 plus, Mg24 is going to be deflected more. If it is deflected more, it would basically not reach the detector as well, right? Because if it is deflected more, it would basically end up being here. It would never reach the detector. Okay, because it is lighter. Let's just think of two people, right? One people is healthy and has greater weight, and one people is light. These people, if you give a push, it would basically fly off, let's just say. But if you try to give a push, it won't, right? Because it is heavy. You basically need more amount of force to move that heavier one. Okay, so yeah, moving on. A sample of magnesium has relative atomic mass of this. The percentage abundance of Mg24 is this. Calculate the percentage abundance of this. Okay, easy. So for percentage abundance of this is given, right? So let's just take total to be 100, right? And subtract 79.4 from it. So you'd get a value 79 from it, and you'd get a value of 21%, right? Now let's just say for 25 is going to be x, then for this is going to be what, x minus 21, right? This should be the MR of it. This should be the abundance. So let's just say for this the abundance is x, then for this is going to be x minus 21, right? And you solve it and you figure out the answer of it, right? So just a moment, I made a simple mistake. So for, let's just say for 25 the abundance is going to be x, then for 26 that is going to be 21 minus x, right? 21 is the remaining one. Okay, so remaining abundance 100 minus 79, 21%. For 25 this is going to be x, so for 26 it is going to be 21 minus x. You basically have the relative atomic mass that was given in the question. You plug it into the value, mass times abundance, mass times abundance, mass times abundance divided by total abundance, that is 100. You figure out the value of x. If you have the value of x, you could easily plug it over here, right? So for this is going to be 12%, and for this is going to be 21 minus 12%, that is going to be 9%. So Mg26, the percentage is going to be 9, and for Mg25 the percentage is going to be 12. Okay, I hope you are clear with this, everyone. So moving on. Okay, so mass spectrum of a sample of bromine is shown. Okay, deduce the mass and approximate abundance of the two isotopes of bromine. Okay, bromine has two isotopes, bromine 79 and bromine 81, right? So what could be the possible combination of this? Okay, the peak ratio is 1 to 2:1. Okay, so let's just see something. For bromine there is two isotopes. It could be bromine 79, it could be bromine 7981, or bromine 8179, bromine 81, bromine 79, or both could be bromine 81. Let's just try to figure out something. The total 79 plus 79, 158, and for this is going to be what, 79 plus 81, this is going to be 160, and for this is going to be 81 plus 81, this is going to be 162. Okay, so for 158 the peak is going to be for this, for 160 the peak is going to be for this, and for 162 the peak is going to be for this. Okay, now for the reduce the mass and approximate abundance of the two isotopes, what I could see is that from here bromine 79 and bromine 81, the abundance of both of the isotopes are nearly the same, to be honest. The both abundance for both of the isotopes of bromine 79 and 81 is nearly the same, is almost the same, you could say. There could be slight difference. Okay, so the peak height for this is going to be, let's just say 1, and this is going to be 1, but for this is going to be 2, twice. Why? This is because there could be two possible arrangement for the middle peak. It could be arranged in this way, or it could be arranged in this way, right? I am not going into the probability thing at this point. If you are still unsure about how to calculate the probability of these bromines or the most common ones of chlorines, do let me know in the comment section. I would make a separate video for that. Okay, since this is a question paper solving video, I'm not diving into the details of those. Okay, but there's a way to figure out the probability of these compounds. Okay, so more or less this is it. Okay, now let's just see what I have written over here. This is just what I have written over here. See, Mg79 and Mg81 are due to monoatomic isotopes of these and this. Mg158 and 162 are due to bromine 2 plus bromine 2 plus comprising of 2 Br79 and 2 Br81 atoms. Peak at 160 is going to be due to Br2 plus comprising of 1 bromine 79 and 1 bromine 81. The isotopes have similar abundance, roughly 1:1 ratio. The 160 peak is double the height because it results from two arrangement, right? 79 and 81 or 81 79, while 158 and 162 only have one arrangement. Okay, so yeah, more or less this is it, and yeah, just take a reading at it, everyone. So yeah, this brings us to the end of this paper. If you find our video to be helpful, then make sure to like, comment and subscribe for the upcoming videos on recent question papers. All the best for your exams, everyone. Have a great day.